Biraz bekleyelim dilerseniz. Bir dakika daha bekleyip öyle başlayalım isterseniz. Evet, başlayabiliriz sanırım. Merhabalar, hoş geldiniz. Ben Sibel Bilgin Köksal. İngiltere Başkonsolosluğu İstanbul'da Birleşik Krallık İş ve Ticaret Bakanlığı'na bağlı Department for Business and Trade diye geçiyor. Departmanımızın adı. Ticaret danışmanı olarak çalışıyorum. Departmanımız İstanbul, Ankara ve İzmir'de faaliyet göstermekte ve Birleşik Krallık ve Türkiye arasındaki ticaret ve yatırımın artırılması için çalışmaktayız. Ticaret ve yatırım olarak iki ayrı ekibimiz var. Ticaret ekibi olarak biz İngiliz firmalara Türkiye'deki yatırım, ticaret ve işbirliği imkanları konularında destek hizmetleri veriyoruz. Yatırım ekibimizdeki arkadaşlarımız ise Türk firmalarının İngiltere'de şirketleşerek iş kurmaları için ücretsiz destek hizmetleri sağlıyorlar. E, Bugünkü webinarımızda İngiliz firma Navteq Radar firmasından alanında uzman konuşmacılarımız sizlere 360 derece uzun menzilli radar teknolojisinin dünya genelinde nasıl devreye aldıklarını ve karayolu güvenliğini nasıl artırdığını aktararak değerli bilgiler paylaşacaklar. Navteq Radar, Türkiye'de aktif olarak işbirliği yapacakları bir ortak arayışında. İlgilenen firmalar olduğu takdirde de benimle ya da firmayla direkt olarak iletişime geçebilirler. Webinarımızda sunum İngilizce olarak yapılacak ve sunumların sonunda da soru ve cevap kısmı olacak. O şekilde webinarımızı sonlandıracağız. Sorularınızı eğer İngilizce olarak alabilirsek çok sevinirim. Ancak Türkçe de olursa İngilizce olarak aktaracağım. Bu konuda da yardımcı olmaya çalışacağım. Şimdi sözü Navteq Radar'ın uzmanlarına ileteceğim, vereceğim. Yes, it's now over to you, Zahir. We are listening to you, your presentation.
Wonderful. Thank you for the warm introduction, Sybil. Hello, everyone, and welcome to a webinar about Navteq's 360-degree radar-based incident detection and traffic monitoring system. Talking to you today is myself, Ozer Beg. I'm a sales engineer at Navteq, responsible for all ITS-related business in Turkey. And with me, I have Kieran Marsh, who is Navteq's ITS product manager, who also brings a rich history of technical delivery experience with him, and who will guide you through some of the technical fundamentals of the system. We hope you will then leave this webinar today with a better understanding of what makes Clearway a high-performing and versatile system. A bit of background for context about Navteq. So Navteq have been in business since 1999, so for around 25 years. And this has allowed us to build our product expertise and experience when it comes to deploying and designing radar safety systems. We have our own purpose-built manufacturing site, enabling us to keep all developmental and design aspects of our system in-house. We were a founder-led family business for 20 years, and at the end of 2018, we joined with Halma, who are a large UK PLC listed on the UK stock market. Halma is a group of engineering companies that work to provide cleaner, healthier, and safer work environments, and Navteq are part of their safety division, contributing to this mission through our advanced radar safety technology. The slide on screen is a brief snapshot of Navteq's progress in that time. In today's webinar, we'll explore Vision Zero and how 360-degree radar technology can help achieve this goal. We'll introduce our radar-based AID solution, and Kieran will explain how 360-degree radar works to increase safety, delivering real-time, all-weather detection of incidents and hazards. Kieran will continue with a system overview, showing how Clayway integrates with existing infrastructure to enhance safety and operational awareness. And from there, he'll highlight the key benefits of radar, and I'll talk through some real-world use cases, focusing on highways and tunnels where rapid and reliable detection is critical. We've also set aside time at the end of the webinar for a question and answer session, giving you the chance to ask any questions or clarify any points we've covered. Please drop your questions throughout the presentation. Before we explore radar technology, it's important to first understand the principles and significance of Vision Zero. Vision Zero is a global road safety initiative with the aim to eliminate fatalities and serious injuries on the roads by 2050. Instead of accepting traffic deaths as just being a part of life, Vision Zero takes a different approach. It looks at how smarter design, safer infrastructure, and responsible policies can work together to eliminate serious injuries and fatalities on our roads. And in 2013, the Vision Zero concept was officially adopted by Turkey as the basis for its road safety policy, as an effort to align with international standards and best practices. In 2024, 6,351 people died on Turkish roads, a 3% drop from 2023. While this shows some progress, it's a clear reminder that far too many lives are still being lost. Efforts like Vision Zero are crucial to accelerate change and move closer to the ultimate goal of eliminating road deaths entirely. And technology has a key role to play in helping to achieve Vision Zero by transforming how we prevent, detect, and respond to road safety risks. As cities and countries strive towards Vision Zero, the integration of intelligent technologies will be essential in making Vision Zero a realistic and achievable goal. Road deaths aren't inevitable, they're preventable. So Navtec's ITS solution Clayway combines 360-degree radar technology with advanced rules-based software to deliver powerful and precise monitoring and detection capabilities. It is used by highway agencies, departments of transports, tunnel operators, toll and concession owners to operate their roads, tunnels, and bridges more safely and efficiently. The 360-degree radar-based AID system detects incidents within seconds, enabling operators to respond swiftly, keeping traffic flowing whilst enhancing safety. It detects along long stretches of highways in poor visibility and adverse weather conditions, improving safety when it's needed most, in conditions where accidents are more likely to happen. When you need your detection system the most is often when conditions are far from perfect. It may even be that the conditions had a part to play in any incident itself. Navtec radars will continue to detect with the same level of performance in fog, snow, rain, smoke, complete darkness, and in bright light and glare. In these situations, being able to reliably detect becomes even more critical to ensure other road users are alerted and diverted appropriately. Incident detection in tunnels can be challenging. Clayway is a proven incident detection solution in tunnels across the world. The 360-degree radars monitor for incidents across your entire tunnel, including at portals and approaches. This is where vision-based technologies can struggle due to the high contrast lighting and variable weather conditions. Automatic camera control adds visual context to alerts, assisting operators to respond appropriately. Clayway provides comprehensive safety features by being able to detect the most serious incidents. These are stopped vehicles, wrong way or ghost drivers, obstruction detection, such as drop loads or rockfall, hard shoulder monitoring, queue detection, vulnerable road users, such as unauthorized pedestrians on the road, and wildlife detection to monitor for animals that may cause serious collisions. From the same radar instrument and software, traffic statistics for the monitored road space are available. Current classification data is also available, again from the same radar and software components. So that's giving you a top-level view of Clayway and how it boosts safety on mission-critical roads. Kieran is now going to delve into some more of the details, firstly by explaining how Navtec's 360-degree radar works.
Great, thank you, Rosaire. Okay, so I'm going to start with a quick explanation of how radar works, and then we're going to get into the details of our 360-degree implementation. So firstly, radar is an active sensor. So in other words, it produces its own signal and processes the reflection from everything within the line of sight of the instrument. This contrasts with cameras that require natural or artificial light to illuminate the scene, which can, of course, vary significantly in differing environmental situations. Time of flight of the radar signal is used to accurately determine the distance of an object from the radar. The time a signal takes to be reflected can be used to accurately determine how far away the reflecting object is. The static radar beam is shaped to cover as much of the road space as possible within its view. For our CTS model, the main beam is approximately 1.8 degrees wide and 1.8 degrees high, with a special dish to fill in the space closest to the radar. On its own, this covers the entire road space within view from around 6 meters of the radar all the way out to its instrumented range of 500 meters. As you'll see next, adding a rotating element to the beam gives this method of detection a distinct advantage. The dish inside the radar rotates at 4 Hertz, so that's 4 times per second, and the beam samples the environment 400 times per revolution. Each beam sample is broken down into approximately 2,800 pixels of 17.5 centimeters, giving a resolution of around 1.2 million pixels per revolution of the dish. This is the fundamental and unique operation of our radar and allows us to have a full 360-degree field of view. From the image on the slide, a single radar can monitor 500 meters of road space over multiple lanes and carriageways with a high detection accuracy. Consecutive scans are compared to look for moving objects. Consecutive scans are also assessed for any changes in the static background. This is a method used to detect any new stationary objects, such as stopped vehicles or other obstructions. Static objects not of interest, such as signs, posts, and gantries, are essentially ignored by the radar and due to their long-term presence in the radar imagery. Once moving or stationary objects are seen for around 4 scans, so that's about 1 second, the radar can begin tracking. Tracking is what I'll talk to you now in the next slide, which is the fundamental feature of the radar output. As the radar scans, it tracks all moving and static objects by ignoring already present background objects and only focusing on what has changed. Each object is sighted on each rotation, so that's 4 times every second, and each set of sightings make up a track for that object. Each radar tracks all objects of interest within its field of view. The properties of these tracks are then assessed in real time by the back-end software against a set of predefined rules. All rules are specifically configured for the project's required applications, such as stop vehicle, runway driving, pedestrians, etc. If any tracks exceed any of these predefined rules, then alarms will be raised. Tracks can also be counted, providing traffic statistics for the entire length of the road or providing count and classification data at specific points on the highway. Tracking and our ability to continuously follow vehicles, pedestrians, or stationary objects over large areas sits at the heart of Clearway's effectiveness. And as we'll see shortly, combining this with the unique benefits of radar means Clearway becomes a powerful tool to enhance safety on roads and in tunnels. So here's a short example of a video demonstrating tracking in action. At the top of the frame, the green circle denotes where the radar and dome camera are co-located. Tracks displayed on the carriageway represent the track information being processed by the radar. At the bottom of the image is a camera footage of the same section of road for context. This tracking of every vehicle is the primary function of the radar and underpins the ability to provide full coverage of long stretches of road. So building on what we've learned about tracking, I'm going to give you an overview of Clearway functionality as a combination of radar and software. I'll also touch on system performance metrics, specifically time to detect, and response times, which is critical from a safety aspect. We'll also look at the kinds of third-party integrations available to connect outputs from Clearway to systems that you may already be using. A single radar can reliably and accurately monitor up to 300 meters of road in a tunnel and 500 meters on an open highway. Radars deployed in series can therefore provide unbroken coverage for many kilometers of road. Radars can be mounted at the side of the road or in the median and are mounted between 4 to 5 meters above the road surface. The radar is a long-range instrument and must have line of sight of all areas it is expected to detect. So, to get the maximum range for each radar, there are several aspects that must be considered. For example, to give a radar the best view around a bend, we tend to mount on the outside of the bend as depicted on the infographic on the screen. This maximizes the range the radar can see, ultimately reducing the total number of radars required on your system. Elevation changes, bridges, and other potential aspects that may affect range also all need to be considered. And on that note, Clearway is designed to be a multi-device system, with each device serving track data for multiple applications. All radars are assigned to a single back-end software instance that monitors and counts each track from every connected radar. Clearway software processes the track data in real time, assessing each track every quarter of a second from all radars against predefined rules and appending them to traffic data statistics. The same software instance acts as the central point for all third-party connections for both alarm and traffic data. And our biggest system to date runs over 100 radars, each with a connection runs over 100 radars, with each connection to third-party systems coming from a single point within Clearway. So, critical situations on the road require rapid action to be taken to prevent and protect those involved in a primary incident and to prevent any secondary incidents that may represent a risk to life. The table on the slide shows time from an incident occurring, moving right through the table, and shows some incidents that may be detected by Clearway. The speed at which an incident is detected and visually verified is critical to minimize any escalation and ensure appropriate action is taken. The radar will begin tracking a new situation within 1 second and can have a fully qualified track within 5 seconds. So if a person enters the monitored road space or a vehicle stops, the radars will immediately begin to track. By 5 seconds, the radar will have seen the object enough times to have a solid assessment of the track to ensure reliable detection. Reliability of detection is paramount in any AID system. This ensures that alarms raised are genuine and false alarms are minimized. Alarms can be raised by Clearway within 10 seconds of an incident occurring. Directing cameras then only takes a few seconds, and the incident response can begin within 30 seconds. Clearway is a versatile tool in the way that it integrates with third-party systems. Data integrations allow connections to third-party traffic management systems, SCADA systems, or PLC logic layers. PTZ cameras can be directly controlled, and there'll be more about this in some following slides. Video management systems can be directly integrated with, and I'll talk more about this as well in following slides. Dry contact relays can also be triggered to toggle on or off connected devices. So specifically looking at data outputs, out of the box, Clearway comes with 3 main data integration methods that are used to send alarm, health, and traffic data to third-party traffic management systems, your SCADA systems, or your logic layers. This data can be fed directly into alarm dashboards in control rooms, leading to the rapid response times mentioned previously. Alarm data can also be fed into control systems where that information can be used to drive third-party logic decisions. For example, initiating tunnel closure signs and barriers when a wrong-way driver is detected, or feeding into variable message sign activation to warn drivers of a potential incident ahead. Health information is continuously fed from all major components of the system. Connection and power issues with any roadside radars will raise alarms, as will software component errors. all of which can be received by operational monitoring tools to ensure easy diagnosis and minimal fault response times. One of the most interesting and powerful integrations Clearway has is its ability to directly control PTZ cameras. Incidents detected by the radar system on the road can be rapidly verified by operators by Clearway directing the nearest PTZ camera towards the location of the incident. This gives eyes-on context of the detected incident within seconds. Any ONVIF compliant camera can be integrated with Clearway. The video playing on the screen shows two stopped vehicles on a road that have been detected by the radar system. You can see the sections are colored in red, and a square icon highlighted denotes the location of the stopped vehicle in each section. Clearway then directs the camera to the location of each stopped vehicle, and on this occasion, periodically switches between the two events. The next powerful layer is the ability to integrate with video management systems. We've already seen the power of Clearway to fuse the power of radar detection with the visual context of camera control. This functionality can now be added to video management systems to integrate with existing alarm management features and to ensure an easy to access record exists of a detected incident. The video on the screen shows a pedestrian being detected on the road by the radar system. Clearway then instructs the camera to point and to follow the target while they're in the road space. So we're an official technology partner with Milestone, and here an alarm is created within the Milestone XProtect Alarm Manager. A replay of the incident can then be easily accessed from the user interface, which is showing on the screen now. So now we've seen the power of Clearway system, we're going to move on to the benefits of radar. What makes a 360-degree radar system beneficial, and how can using radar make your roads safer? So firstly, some words on the benefits on open highways. Radar is not affected by variations of natural or artificial lighting, so it doesn't matter if it's too dark, too bright, low sun angle, or dazzling headlights. Radar is also not affected by weather precipitation particles in the air. Many of these situations are when you need your AID system to be at its most effective, and is one of the main reasons to choose a radar system for detection. And as we've seen in previous slides, full coverage can be achieved with radar spaced up to 500 meters apart along the road, remembering you get multiple capabilities from the same device. This results in a clear benefit on open highways by requiring low infrastructure footprint as a result of its long range. In tunnels, research statistics show that the highest collision rates are at the tunnel portals and tunnel approaches, and less so in the interior zones of the tunnels. The portal and approaches are defined as areas within 150 meters of the tunnel entrance. This is where light-based monitoring technology often struggles with variable lighting and weather. Radar is unaffected in these conditions and maintains full detection capability. Smoke in tunnels is also a major concern when the unthinkable happens. Do you have a system that is able to continue to detect people and cars in a smoke-filled tunnel? In the unlikely event that this should occur, it could prove to be crucial. So Navtech upgraded our original belt drive motors a few years ago, and we've since replaced them with a new direct drive motor system. Our new motors don't require any servicing during their 10-year life cycle, meaning no roadside maintenance is required for the lifetime of the device. Highways and tunnels can be harsh environments for any ITS equipment. Dirt, dust, and soot soon coats anything left exposed. The sealed IP67 radar enclosure ensures the internals remain uncontaminated, even to the harshest road environments. The slide shows an older V2 CTS 350 in the center picture. This radar is still operational in a UK tunnel and has been in use for nearly 10 years. Here you can see this unit has not been cleaned for some time, if at all, yet still maintains its full capability. No roadside maintenance means fewer roadside visits by maintenance crews, keeping them out of harm's way. During system design, existing infrastructure such as gantries, ITS posts, and variable message signposts can be used to mount radars. This means existing power and network connections can be used, saving the additional cost of running new fiber and connecting new power terminals and network switches. For tunnels, radars can be placed in locations that better suit connectivity. Brackets are usually attached by inserting 4 studs into the tunnel wall at the design location. Once the prefabricated bracket is attached, the radars are simple to install. 4 bolts attach the unit to the bracket, and then 2 simple connections for power and network. PoE, Power over Ethernet versions of our CTS radars are also available, meaning existing PoE infrastructure can be utilized. Each radar requires leveling to the angle of the road. This process usually takes around 1 to 2 hours for each radar. During this time, the engineer will adjust the leveling plate on the bracket to ensure optimal performance in all directions, remembering this is a 360-degree device. The engineer will also run a series of on-road tests and gather data to ensure accurate records are kept of the performance of the radar at the time it was installed. With a 360-degree radar system, operations room now have an eyes-on system monitoring their entire critical road space. Operators can quickly assess their priorities and focus on incidents that require their highest attention. They then spend less time relying on scheduled camera scans in the knowledge that the radar system is monitoring the road on their behalf. Combine this with the ability to continue detecting in poor environmental conditions and requiring fewer road visits, all stacks up to making roads safer for road users and maintenance crews alike. So there is your overview of 360-degree radar. We have touched on Clearway's powerful integrations, on Clearway's safety and efficiency features that all come as a result of full coverage and minimal roadside interventions. I'm going to hand you back to Auxerre now, who's going to talk about some real-world use cases of Clearway to demonstrate where Clearway continues to make a difference to road safety and efficiency.
Thank you, Kieran. So part-time shoulder highways require full coverage of the part-time lane and all adjacent lanes. This is to ensure there are no obstructions before opening the lane. Monitoring for any incidents where the part-time shoulder needs to be close to traffic outside of the schedule is also critical. Navtex Clearway is installed on the A4 motorway outside of Milan in Italy for this very purpose. On this system, Clearway is monitoring for any stopped vehicles when managing the opening and closing of the part-time shoulder, and is also being used to gather traffic count information, which is passed to the operations center. Radars are co-located with PTZ cameras that are controlled to provide near-instant verification of any incidents detected by the radar. The decision was made around 5 years ago to remove the hard shoulder on a number of strategically important highways in England in an effort to increase capacity and reduce congestion. These are referred to as all-lane running systems, and Navtec were chosen as a safety system to monitor these all-lane running systems and provide highly accurate and rapid responses to any stopped vehicles on any part of the road. Emergency bays are placed approximately every half-kilometre to provide safe refuge, and our system provides specific alerts for vehicles stopped in these bays. Over 1,200 radars are deployed across 30 separate systems spanning 400 kilometres, making it the largest all-lane running system of its type anywhere in the world. Navtec are trusted to provide coverage and the response that a system of this complexity and profile requires. For roads that require full coverage to monitor for incidents and to count and classify traffic to feed into concession key performance figures, Clearway is also a proven solution. Clearway is being used to monitor 27 kilometres of highway and 15 connecting ramps on Transmission Gully in northern Wellington, New Zealand. Here, full AID functionality is provided to ensure incidents are dealt with quickly and within required response times. Count and classification data is fed to the road authority, where it is used to demonstrate traffic flows and ramp performance, which are all within set key performance figures. In road tunnels, Navtex Clearway delivers an always-on level of awareness that provides full detection inside the tunnel, at the portal, and beyond into the approaches. Navtex's benefit of not being affected by tunnel portal lighting conditions means incidents that happen in or around the portal are detected with the same performance as any other part of the tunnel. Clearway is trusted to be installed in over 15 tunnels in Norway, ranging from 300 meters to 15 kilometers in length, where it's used in some tunnels to automatically trigger tunnel closure systems in the event of a wrong-way driver. Clearway's ability to control PTZ cameras and bookmark video management system recordings adds another layer of confidence to a situation where rapid response may be critical. If the worst should happen and the tunnel becomes filled with smoke, Navtex 360-degree radar still provides full detection capability when you need it most. And the Stockholm Bypass project, it's one of the biggest infrastructure projects in Europe. Unix Traffic were chosen as the ITS provider, and Navteq was selected to provide our 360-degree radar technology to monitor sections of the open highway and to provide reliable detection at the tunnel portals. This is to ensure reliable detection is achieved in the variable lighting zones entering and exiting the tunnels. Finally, to finish on more roads in Stockholm, almost 140 radars are in operation on some of Stockholm's busiest roads that now include the E4, the E18 and the E20. Stockholm was in fact the first ITS installation for Navteq almost 15 years ago, and many of the major routes in and around Stockholm suffer from heavy congestion, and any incidents could bring many kilometers of traffic to a standstill. Our Clearway installation has steadily grown over the years and even includes the 2-kilometer Tornskog tunnel in the northern suburbs of Stockholm. This system continues to be in service to this date and is supported by our in-house service delivery team. So now you've seen the real-world benefits of Navteq's 360-degree radar system can bring and the scale of the systems Navteq are trusted to deliver. I'm now going to share our performance guarantee and outline Navteq's ongoing support services available for the lifetime of your system. So all systems designed by Navteq come with our performance guarantee. If we design a system to an agreed specification, we will guarantee we will deliver the system to meet that specification. Specified metrics can include detection rates, false alarm rates, and time to detect rates. At Navteq, we don't just build our radars and design our software. We also deliver fully functional systems with our highly experienced in-house engineers. We can work anywhere in the world to ensure that you get the maximum expertise when delivering your system. We can commission and test radar systems at the roadside and can even support operators in the traffic management centers. Beyond successful delivery, we will continue to support your Clearway installation for the lifetime of the system. Our ITIL4 service management desk can provide first, second and third line support with 24/7 access available if required. As previously mentioned, some of our earliest systems were delivered almost 15 years ago. These systems are still in service, providing critical safety functions in and around Stockholm, and we continue to work closely with the customer to this day. The slide on screen shows one of the first radars ever deployed on a Navteq ITS project in Stockholm, still in service today and fully supported with the customer. All the while, Clearway has been keeping road users safe with ongoing support to ensure uninterrupted service. Before we close, we'd like to make a call to action. We're looking for high-quality technology partners to help us deliver safer roads across Turkey. Please feel free to reach out if you think you could collaborate and partner with us as we do our part towards achieving Vision Zero. If you're a road operator or a system integrator and are looking for a high-performing incident detection system, please contact us and we will happily work with you to develop a solution to solve your problems. So in conclusion, we've covered how 360-degree radar provides full coverage for your critical road spaces, either on open highways, bridges, or in tunnels. We've also talked about how Clearway's functionality and its rich integrations provide rapid responses to critical on-road incidents. We've also shown that by controlling PTZ cameras and integrating with your video management systems, full context can be given on an incident within seconds. We've covered how radar is beneficial as a detection technology, ensuring accurate detection in poor visible conditions. And we've gone through various use cases of Clearway in the real world. Vision Zero is a call to action for all of us to ensure that people's journeys on roads are safe, and Clearway is a proven solution to get us there. Road deaths aren't inevitable, they are preventable. So that is the main body of this webinar now concluded. I'm going to pass over to Sybil now, where we're going to start the question and answer session.
Yes, thank you very much, Kieran and Zaire, for a very comprehensive presentation. So we can now start questions and answers session. Soru ve cevap kısmına geçebiliriz webinarımızın. Sorularınızı chat kısmından iletebilirsiniz bize. Ben de soruları yönlendireceğim Kieran ve Özeyir'e. Herhangi bir sorusu olan varsa soruları yönlendirebilir. Aksi takdirde ben birkaç sorum olacak. There is no question seems to be from the floor, so perhaps I can ask you a few questions. My first question is that is there a minimum mounting height for the radar units for highways compared to tunnels?
Yeah, I can answer that one.
Yeah.
So on highways, typically we mount at 4.5 meters above the road surface. Obviously, in tunnels, getting that high isn't usually possible. We try to mount as high as we can on a tunnel wall, but obviously keeping the radar out of the traffic envelope. But yes, on highways, the typical mounting height is 4.5 meters above the road surface.
And in tunnels, I believe the best optimal mounting height is 3 meters, I believe, in a tunnel.
Yep, 3.5, it depends on the tunnel design quite a lot as well.
Thank you. And what is the mean time before failure of the radar then?
So figures from our workshop give mean time before failure is 12.8 years.
That's great. Thank you. And any other questions? Başka sorusu olan sormak isteyen var mı? Biraz daha bekleyip dilerseniz webinarımızı kapatalım. Sanırım bir soru yok. Webinarımızı kapamadan önce özellikle ben Türkiye Akıllı Ulaşım Sistemleri Derneği'ne bize bu fırsatı tanıdıkları için çok teşekkür etmek istiyorum. Herkese çok teşekkürler katıldığınız için. Aslında iletişim bilgilerimi ben de chat'e yazacağım. Herhangi bir sorunuz olduğu takdirde herhangi bir İngiliz firmayla İngiliz firmaya iletişim konusunda benimle iletişime geçebilirsiniz. Ancak bu arada çok pardon, bir soru görüyorum. I've just seen a question in the chat. Is there a roadmap about integration with other traffic management components, with traffic control centers or V2X RSU technologies, and or supported standard integration interfaces and protocols?
So at present, we integrate with traffic management systems. We have generally our main interface is an XML interface that we integrate with systems such as Capture's Dynac. So we do integrate with other traffic management systems as well on a project-to-project basis. We have our own software team. So if there is a new integration that needs to be introduced into a project, then we have our own software team to ensure that we can do that. But we are happy to talk to integrators and customers in terms of integration with other systems and introducing new protocols if that's what the project requires. So in terms of the roadmap, we're looking at potentially introducing some easier ways of integrating with Clearway. But if people like yourselves come to us with new proposals that you think are going to enable better integration between our systems and third-party systems, then we are more than happy to listen.
Thank you. Thank you, Kieran. Bu arada başka soru var mı? Tekrar sormak isterim. Kapatmadan önce. Sanırım başka soru yok. Çok teşekkürler hepinize katıldığınız için. Ben iletişim bilgimi hemen chat'e kopyalayacağım. Herhangi bir İngiliz firmaya ya da kuruluşa erişmek istediğinizde benimle iletişime geçebilirsiniz. Bu arada bir de soru geldi. There is another question from Ertaç Dursun. We have equipment such as VMS, VTS, and fog warning flashes on our highways. Can we integrate this equipment into our software to perform automated routing?
Absolutely, we can. So what we've done on other projects, so we wouldn't necessarily integrate directly with your variable message signs or your flashes, although we can do that. On a larger project, we would typically integrate with your SCADA system. So your SCADA system would receive our alarms, and then that would then trigger something like a variable message sign in that area. So say, for example, the radar system detects a stopped vehicle, that can then be read by your SCADA system, and then your SCADA system can then tell the variable message sign that to be careful that there is a stopped vehicle up ahead. We are able to trigger things directly using, we have a dry contact relay. These tend to be used on smaller projects, but it's still perfectly available. So the dry contact relay is essentially a toggle on or off. So if our system detects an incident, we can use that alarm to then switch on or off a connected device, like a flashing sign or a beacon or a message sign. So yeah, there are a number of ways of integrating, and again, we're always happy to talk to yourselves about further integrations if we can't do it.
Evet. Başka bir soru var mı acaba? Tekrar bekleyelim. Thank you. Let's wait for a few minutes if there is any question, and then we can close the. Yes, there is one more question on the chat from Ertaç Dursun. Thanks. Are there any sample videos or images regarding automation?
So in terms of automation, I presume you mean camera control, or I think what you may be talking about is automation with third-party systems. So we do actually, I don't have it available. We've got a video available of a vehicle that was detected driving the wrong way in a tunnel. So the vehicle was detected by the radar driving the wrong way in the tunnel, which then triggered the automatic tunnel closure system. And so within that video, you can see the red X's being raised above the lanes, and you can see the speed signs also changing as well. So we've got a few sample videos of automation, but essentially it's down to what you can do with your SCADA system. So the radar system will issue the alert if you're and then you can build logic on top of the alerts created by the radar system to then automate whatever it is that you've got connected to your SCADA system. I hope that answers your question.
Thank you, Kieran. Yep, thanks. Başka bir sorunuz var mı? Soru var mı? Biraz daha bekleyeceğim. Ancak yine Navteq radarla ve teknolojileriyle ilgili herhangi bir sorunuz olursa bana ya da Özeyir'e ki e-mail adresi ekranda görüyorsunuz. Direkt olarak bizimle irtibata geçebilirsiniz. Biraz daha bekleyeyim. Daha sonra kapatalım webinarı. I'm just waiting for a few minutes to see if any questions on the chat. And I'll close the webinar. Evet, sanırım başka bir soru gelmiyor. Dediğim gibi bana ya da Özeyir'e sorularınızı iletebilirsiniz. Tekrar katıldığınız için çok teşekkür ediyoruz. Ve tekrar Türkiye Akıllı Ulaşım Sistemleri Derneği'ne tüm destekleri için ve bu fırsatı bize tanıdığı için tekrar teşekkür etmek istiyorum. Bir sorunuz ya da herhangi bir almak istediğiniz bilgi olduğu takdirde mutlaka direkt olarak e-mailinizden bize ulaşabilirsiniz. We would like to thank you for giving us the time to present to make our presentations, and especially to OVS Türkiye team to support us. So thanks a lot. But I just noticed that there is a question or coming on the chat. Yeah, it's all
Thank you.
Thanking you all for the presentation. So thanks a lot. And thanks a lot, Kieran and Özeyir, for this excellent presentation. Thank you.
Thank you for having us.
Our pleasure. Thank you for your attention.
Yeah. Have a nice day. İyi günler diliyorum. Hoşça kalın.